In Java, you often have to deal with groups of objects. For example, a Java program that lets you manage your personal and business contacts may need to keep a list of contact objects. A drawing program may need to keep a list of shape objects that are on the screen. One way to keep this list is by using arrays. We saw arrays earlier in Module 3. We used them to group primitive data types like ints and floats, as well as object references like strings. Here's an example of a simple contact class. Here are the instance variables for this class. Here's the constructor. It just sets the name, telephone number, and whether this is a business or personal contact. Let's use this class in an application. Here we create an array of 3 contact elements. Let's instantiate a few objects and add them to the array. Now let's go through the array to retrieve them. Let's compile. As useful as they are, arrays have a few disadvantages. The size of an array is set when the array is first created. It cannot grow. This can be a problem if you don't know ahead of time the number of objects you need to keep track of. For example, if your contact info was coming from a file or database, the number would not be known at the time you are writing your Java application. In cases like these, you have 2 choices. Either create a very large array in anticipation of the worst-case scenario, or put a hard-coded limit, say 500, for the number of contacts allowed in your application. Obviously, neither solution is elegant or very flexible. Another problem with arrays is that they don't shrink. You can't really remove an element from the middle and expect the array to close the gap. Arrays are a good choice as long as the total number of the objects is known and that number doesn't ever change. But for a more flexible grouping of objects, we need to use one of Java's many collection classes, like array lists or hash maps. We'll see them next.